Welcome back to Autologic Lab. Today we are building a simple and smart light sensor project using Arduino and an LDR. This tiny sensor can detect light intensity and automatically control devices, just like street lights that turn on at night and off during the day. We will learn how it works and we will see the circuit connection, how we are connecting and test it live using LED. Okay, so let's get started. Here first of all we will see what is LDR. Means a light dependent resistor. It is a type of sensor whose resistance LDR detects light intensity. When it is dark, the LED automatically turns on, and when it is bright, the LED turns off. It helps understand how sensors work and how Arduino can be used for automatic light control in real life applications like. And then we have hardware components used in this project is Arduino UNO, LDR, photoresistor and 10 kilo ohm resistor, LED and breadboard and jumper wires. We will see the coding part as well and working with the hardware components. I will show. These are the hardware components used in our project. This is the breadboard. I think everyone know the connections of this breadboard. Still I will confirm once. This is the positive and negative. We can connect positive terminal here and negative terminal here. These are horizontal connection. Same here in downwards, positive, negative. These are a horizontal connection. Now here A, B, C, D, E, F, G, H, I, J. These are vertical connection. For example, I am connecting fifth line A5, A, B5, C5, D5, E5 are connected together. F5, G5, H5, I5, J5 are connected together. These are vertical connection, these are horizontal connection. And then these are the jumper wires, and we have this Arduino board, Arduino UNO and cable, and we have this LDR light dependent resistor. Today we are going to do the project with this resistor. This is a sensor whose resistance changes with light. Means light dependent resistor also we can say in short. And then it means bright. If it is the environment is bright light, then it has low resistance, and if the environment is dark, then it is high resistance. When connected with a resistor as a voltage divider, it produces a varying voltage that Arduino reads through a analog pin code part. This allows Arduino to detect light intensity and control devices like LED. We are using LED. If you have any light also, you can use that. Street lights, alarms and automatic lamps also. It is a low cost light sensor, and it works in only analog input because it varying voltage. Now connecting hardware parts. Take one LDR sensor and connect one ground to A0 and another to negative terminal of the breadboard, and one terminal connected to A0 on Arduino and connected 5 volt to breadboard and ground to breadboard. Now take one resistor and connect one end to A0 and then connect another end to ground on breadboard. See, now we have connected LDR successfully. Now we need to connect LED for light. Now coming to the coding part, LDR one leg is connected to 5 volt, another LDR leg is connected to A0, resistance is connected to A0 at one end, another end is ground. Now LED also I have connected, right? LED one pin is connected to digital 7, negative is connected to ground. Here initialize variables LDR pin equal to, I have connected to analog A0, so A0, LED pin which is connected to digital pin 7, so 7, and LDR value the stored the sensor reading, so I will use this in further void setup. Pin mode of LED pin output, it tells the Arduino that the LED pin will send signals, turn on or off. Serial dot begin 9600 is the baud rate. It starts communication with the computer at 9600 baud rate. This allows to see the reading in serial monitor. Okay, and then loop main function LDR value equal to analog read of LDR pin. It reads the voltage from LDR circuit value between 1020 0 to 1023, and then println. I am printing the LDR value here. And then if LDR value equal to less than 100, means it, if the light value is below Arduino thinks it have means it's dark. Arduino thinks that it is dark, so it turns on the LED. For that, digital write turning on the LED, so digital write of LED pin on, right? So I am using here high. So it turns on the LED, else it turns off the LED. So else condition digital write of LED pin comma low. Compile it. Here I am getting error. What's the error? Here I am missing the semicolon, expected semicolon before flower bracket token. So modified. Now I will compile it. Done compiling. I will upload it. Uploading is also done, and then go to serial monitor. Here I am getting some values, that is 110, 112, that is higher than greater than 100. So LED off. I'm keeping my hand in sensor, so it is dark, it is less than 100, so LED power off. Arduino thinks it was dark. Here the values are 112, 1110, which is greater than 100, means it is not in dark condition. So my LED light should turn off. So it is off. Now I am in dark condition. If I am giving dark condition, like if you see here, the value is 21 and the LED is turned on. If I remove the hand here, the 10 LED is turned off and the value of this LDR highly increases greater than 100. This is the light sensing project using Arduino was done. If you have any questions or doubts about this project, feel free to ask in the comments. I will get back to you as soon as possible. Subscribe for more interesting embedded and automation projects. Thank you for watching. Until then, bye bye. See you in next video.